Hi, I'm Andy Gallagher, Red Hill Soils, based in Corvallis, Oregon. And today I'm going to demonstrate how I make profile description from the soil cores that you saw pulled in an earlier video. I look at the soil profile to classify it, make an estimate of available water holding capacity, the depth to a high water table, and the rooting properties of the soil. And we'll use this to relate back with the dry farm data, crop yield and soil moisture meters in the ground. And so I'm going to walk over and we're going to look at 3 soil cores that were pulled for evaluation. So these are 3 soil cores that we pulled as part of the Dry Farm Collaborative. This one in the center is a Chehalis silty clay loam, which is from the tomato trial. And this soil on the other side is a Willanche soil from Southern Oregon coast. And this soil is a Dayton soil from the Willamette Valley. You can't see many horizons in this center one or that one. You can see quite a few here, and now I'm going to wet up the soil profile because that's how I evaluate the color, the texture, and the moist consistence. So you can see this Dayton soil profile. You can see the A horizon is a little bit darker, and as I spray water on it, the soil color is revealed. You can see the soil horizons as we go deeper. This is the top, and I'm working down into the subsurface and then the clay subsoil. And the soil's changing color, and the reason it's changing color is because there's different horizons have different properties. Up at the top, there's more organic matter, and as you go deeper, there's less organic matter. Here we have an area where there's a high water table and the iron has been reduced and washed out, and we get a gray color here. And then where the iron precipitates, we get a little bit browner color, and we get this redoxamorphic color, gray and red, and that indicates where the high water table is. In the profile in the center, the Chehalis, we've got uniform dark colors all the way down to 4 or 5 feet. And so that soil doesn't look very exciting from a color standpoint. Over here, closest to me, is the Willanche soil. It's a poorly drained sandy loam soil from Southern Oregon. And you can see as I wet it up, it gets darker. This soil also has fairly evenly distributed organic matter, and it's got a sandy texture. And so what I'm going to do today is go through and break the soil up by horizons and then show you how I describe a soil profile. So now I've got the soil core in front of me, and I'm going to look at this soil, and first thing I'll do is the soil color. Some of the cores that we looked at earlier had a lot more distinction between colors. This profile is pretty dark all the way through. But I've separated the soil into soil horizons. This is what we call the plow layer, or the AP. This is the AB, where we have a transition from the surface to the subsoil. This is the BW, and this is the BW2. So when I do soil color, I'll use the Munsell Soil Color Chart book. And what this is a color book that has standard colors so that all soil scientists all around the world are using the same chart. And I'll take a soil that's been moistened, and I'll just hold it up to the color chips. And like in this case, we have a 10YR hue with a 2 value and 2 chroma. 10YR 2. Now that's pretty dark soil. And now this color is from the BW, the B horizon, down around 55 inches. And it's a little less organic matter. I call it a 10YR 4.4 or a 10YR 3.4. So the next thing I'm going to look at is the soil texture. That's the relative amounts of sand, silt, and clay. And the way we do that is with, we call it hand texturing. So I moisten up a sample of soil, and then I work it up really well with my hands, try and turn it into a putty. And then I try and make a ribbon. And there you can see I can make a pretty good ribbon with this soil. And I'm guessing this has around 30% clay. So what you see is the textural triangle, which allows us to take the percentage of clay, silt, and sand and come up with a name for the soil texture. In this example, we have about 30% clay, and we don't have very much sand, probably between 10 and 20% sand. So that puts us in the silty clay loam texture. We have 60–70% silt in this sample. And so why take the texture of the soil? Well, the texture of the soil, percent sand, silt, and clay, affects the particle size distribution, which is very closely controls the available water holding capacity of the soil. And in a dry farm situation, the only water that's available to the crop is the water that's stored in the soil. And so it's important to know what the available water holding capacity of the soil is. For this Chehalis silty clay loam, this profile in the top 5 feet can hold about a foot of water. Another important soil property is the soil structure. That's how do the individual sand, silt, and clay particles come together and form soil aggregates. These particles are bound together by the clay, by the organic matter, by all sorts of organic compounds in the soil, and form soil aggregates, or PEDs. And we evaluate these soil PEDs. This is from the surface of the Chehalis silty clay loam. And this soil has what we would call a moderate to strong structure. Most of the particles are in a soil aggregate, and it's got a kind of a granular structure. And so down here in the subsoil, we have a different soil structure. This structure is a little more blocky. The surface was granular. This structure is blocky. And this is what we call subangular blocky, because they're sort of rounded corners and still moderately good structure in this soil. This is related to how available it would be for roots to move through. If we don't have good soil structure, there's no place for the roots to go. So we've done soil color, soil texture, and soil structure. And now we're going to look at the soil consistence, the rupture resistance of the soil aggregates. And this is something that we're looking at being important in terms of response to dry farming. Whether or not the roots can penetrate and how quickly the roots can penetrate may be related to the soil consistence and the moist rupture resistance. So here's a surface sample I have, and I'll take a soil PED. Generally you want a PED that's about 1 inch, but we don't have any that coarse in the surface, so I'll take about a 1/2 inch one and just squeeze it, and this just crumbles under very gentle finger pressure, and so we consider that to be friable. Friable is a good word if you're a farmer. You want your soil to be friable. Here's a subangular block about 1 inch or 3/4 inch diameter from the subsoil, and it's a little bit more firm, but still not all that firm. As the soil dries out, this will become much harder to do, and so we will consistently moisten it up before we determine the consistency of the soil. When we're looking at a soil to determine the seasonal high water table depth, we're looking at the soil colors. And I've swapped out the Dayton soil for the Chehalis. The Chehalis is well drained, so we're not going to see redoxamorphic features in the Chehalis. In the Dayton soil here, we will. And that's what I want to show you next. So here I've taken a chunk of the Dayton in the B horizon, and you can see the alternating colors, gray and brown, and I'm going to wet it up a little bit to see if it becomes easier to see. There's brown soft masses of iron here and depleted areas in the gray zone. And that just indicates where we have a fluctuating water table. In the Dayton, that's right up close to the surface. And this can affect how quickly roots can develop in the spring. If the site is real wet, roots will develop a little slower because they won't have oxygen. So that has been a brief overview of doing a soil profile description for the Dry Farm project. One of the things that we do with all of these properties is classify the soil. You notice I've been using a soil name for the different soil profiles. We have the Chehalis silty clay loam, the Dayton silt loam, and the Willanche sandy loam. And these soils all have properties that are tied to the soil series. So it's important for us to be able to name the soil, because then you can look up all the other properties of those soils online at the Web Soil Survey or in the County Soil Survey Manual. So the goal here is to classify the soils for a couple reasons. One is to be able to extrapolate the research out into the larger world. And the second reason is so that you can use soil information from your site to determine if your site is going to be a successful dry farm site.